Welcome to another topic in this module. The topic is bitfields. Now again, it is similar to the union, and it is also designed. To conserve memory, or where the memory is more important, or at least you want to use the memory efficiently, then you go for what are called as bit fields. As the name indicates, they are the fields similar to the structure field and union field. But usually when you consider structure and union, you measure the memory in terms of bytes, whereas here we measure the memory, we allocate the memory in terms of bits. Bit fields is a series of individual or chunk of bits, that means group of bits, chunk of bits. So it is chunk of bits. Again, what is the problem? So bit field is a series of individual or chunk of bits, which have different meaning. Bit field is one in which field's length is measured in bits. This is the important point. Field length is measured in bits rather than bytes. They are used when the memory is precious, or you want to use the memory efficiently. Use when you have a flag data. In some fields, say computer networks field, you have different types of flags. I cannot get into the details of the computer network, but in some fields you have to deal with flags of data. That means usually flag means 1 bit or 2 bits will be maintained. So in such cases you can go for bit fields. Note that with 1 bit 2 values are possible, with 2 bits 4 values are possible, and in general with I bits 2 to the power of I values are possible. This is the general rule. Now why we have to discuss, we'll see. So with I bits, the number of possible values is 2 to the power of I, ranging from 0 to 2 to the power of I minus 1. Not 2 to the power of I minus 1, 2 to the power of I minus 1. Bit fields are defined using structures. General format is struct name, data type, bit field name. So it's similar, followed by this colon, followed by and size in bits. So this is where it is different. Okay. So that declaration is followed by colon, followed by size in bits. Example, here you can see struct number unsigned int 1 2 3. Okay, so these are normal declarations, but colon followed by 1, that means the 1 occupies 1 bit, 2 occupies 2 bits, 3, that means 3 occupies 3 bits. So total all put together will occupy 1 plus 2 plus 3, that is 6 bits only. Unsigned int is used as signed representation, uses 1 bit for storing the sign. So we don't by default. Actually the issue here is, if you declare like this integer x, say, so in that case actually the x is of sign type. By default it is sign type. So in the case of sign type, 1 bit is used for sign to indicate whether it is positive or negative. So here we are not interested in the sign, so we are interested in using the memory efficiently. That's why we go with only unsigned integer. Unsigned integer. So one better example is representing the clock, 24-hour clock, using bit fields. So if you consider 24-hour clock, so you have hours, minutes, seconds. You have hours, minutes, seconds. Now how many hours are there in a day? So 24 hours. What are the possible values? 0 to 23. 0 to 23. These are the possible values. If you take minutes, what are the possible values? 0 to 59. 60 can be again taken as 0. Okay, 0 to 59. 0 to 59, or you can use 60 also, doesn't matter. Okay. So if you want, you can use here also 0 to 24, doesn't matter. Okay. Now how you treat the data, how you manipulate the data, that matters. But anyhow, we'll consider it as the possible total of 24 possible values. So for in the case of hours, so it is 0 to 23, is 0 to 59. Similar is the case with the seconds. Seconds is also 0 to 59. 0 to 59. 0 to 59. Now, so this hours is represented using only 5 bits. Minutes, seconds are represented using 6 and 6 bits. Why? So with I bits, the total possible values is 2 to the power of 5. With I bits, total possible values are 2 to the power of 5, ranging from 0 to 2 to the power of I minus 1. Ranging from 0 to 2 to the power of I minus 1. That means what is 2 to the power of 5? 32. That means 2 to the power of 5 is 32. 2 to the power of 5 is 32. Okay. So you can represent hours with because the value is below 32, you can use 5 bits. Similarly 6 bits, so it is 64. So 0 to 59 can be represented. The maximum possible value is 64. So you can represent these values. Similar the case with this one. So here you can see, you can say reasonable application of bit fields. Reasonable application of bit fields. The memory allocated is in multiples of size of integer. Multiples of size of integer. Assuming the size of integer as 4 bytes, if the bit fields put together occupy space which is less than or equal to 4 bytes, then 4 bytes is reserved. So, but though we are saying that the memory that is required is say 5 plus 6 plus 6, 12 plus 5, 17. So, but memory reserved is in terms of multiples of size of integer. So, if you consider the integer as 4 bytes, then if you require less than that, then the amount of memory that is reserved is 4 bytes, at least 4 bytes. So, the memory that will be reserved for bit fields is at least 4 bytes. Okay, 4 bytes, that is how many bits? 32 bits. Up to 32 bits it is only 32 bits or 4 bytes. Beyond that again you add another 4. 4 plus 4, that is 8 bytes. That is the memory allocated is in multiples of size of integer. It depends on size of integers. Assuming that size of integer is 4 bytes, the minimum amount of memory that is reserved is 4. So better option, instead of using unsigned integer, better option is to use unsigned short or unsigned char. This we will see. So instead of using unsigned integer, many books use only this unsigned integer. So but you can use unsigned short, unsigned char. Whether this compiler permits or not, we will see. How to deal with the gaps? Maybe from C programming this is not required, but if you consider these programming examples, etc., so you will be having flag bytes. Usually in between there will be some free bytes or reserved bytes. So you have to deal with those things. Suppose the representation is like this. This is one field which requires say 1 bit. F2 is another field which requires 2 bits. F3 is another field which requires 3 bits. But they are not consecutive. So in between there are 2 fields which can be considered as reserved fields. This is of 1 bit. This is of 1 bit. So F1 requires 1 bit. F2 requires 2 bits. F3 requires 3 bits, but they are not contiguous. 2 reserved bits are there in between. Then what happens? Then you have to create the structure like this. You have to create the structure like this. If you want gaps, then how much gap that is required? That should be treated as one field. Here you require 1 bit R1. So 1 bit that is reserved. So you have to declare it. But actually data is stored in F1, F2, F3 only. But the gap should be filled with some fields. So applications, use it for any application where you want to use the memory efficiently. Use it particularly in computer networks field where we deal with different flags. In general, use it in low level programming while using registers. While using registers also we use bitfields. Again in the embedded systems, etc. we go with the bitfields. So don't underestimate a bit. It can be it can make a difference between success and failure. Thank you.